following video will demonstrate how to build an interactive number line using embedded components. Specifically, this example will show how to use the embedded plot component to retrieve input from mouse click actions and to use that input to create a point plot that displays a single point corresponding to the area clicked. This video will be comprised of 5 sections. We'll start by discussing how to create a new plot component, as well as some of the properties of embedded components. We'll then talk about writing action code that can drive your embedded components, as well as retrieving input from embedded components. And as a conclusion, we'll follow up and put all these things together in order to build an interactive number line application. So let's begin with our first section, and this is just an easy one. This is just talking about creating a new plot component. So if we have a new Maple worksheet, and this is a new Maple worksheet that I've got with an embedded table, what we can do in order to create a new plot component is simply go over to our palettes, and if you haven't done so already, then we can expand the component palette. If your component palette isn't open, we can show the palette by right-clicking on the palette dock and choosing to open the components palette. Once we have the components palette open, we can click somewhere in our worksheet that we want the plot to appear, and then we'll go down and we'll choose this icon here. If we hover over this, it'll just show us plot, and this will create a new plot component for us. In our second section, we'll discuss the properties of embedded components. So every embedded component has attributes that determine its appearance and contents. For plot components, such as the one we created in the previous section, this includes properties such as name, size, as dictated by pixel width and pixel height, contents, which is our value option, and more. This section outlines how you can gather information about and pass information to the plot component. So to begin, it's really important for us to note how we can pass and retrieve information about properties to and from components. So what we saw when we inserted the plot component in the previous section was the plot component did not contain any plots by default. So it just simply reads embedded plot window. So one of our first tasks is to add a plot to the plot component. But to do so, we need to know where to send information. And the key piece of information we need to know, in this case, is our name. So all embedded components have an identity, and this is known as this name variable. So to find the name of the plot component, we can right-click on the plot component, and we'll choose Component Properties. And the first item listed on our plot properties window here is the name of our component. So in this case, our name is going to be plot0. We can also observe from this plot properties that there are other attributes listed here. So here, as we mentioned before, is the width in pixels, the height in pixels, as well as animation delay, and if we want to have a border around our plot component, as well as a few more options. For right now, I'm just going to click OK. We've got our information that we need, and we can move on. Now, in order to programmatically send or retrieve information to the plot component, you can use the Document Tools set property or Document Tools get property commands. So I've included these as help links, so let me just open these up as our help pages just so we can get an idea what these look like. So the Document Tools set property simply sets the property of an embedded component. And its calling sequence is such that we use the ID, or the name of our component, the attribute, or the property we'd like to change. So this could be our plot expression, our value. It could be the pixel width, the pixel height. The third option here is our value. So in this case, it would be if we want to change the pixel height, we like to change that to a number. And our fourth option, which we won't be showing today, is a refresh option. So let's do an example with set property. And in this example, we'll use the set property to set the pixel height of the plot component plot0. As we observed before, the pixel height was 400 by 400. And as we saw from the help page, the first argument in the set property command is going to be our name. So we got this from before, so the name is plot0. And I've put this in a string just so we know exactly which name we're dealing with. You can also put this in using backticks in order to declare this as a name in Maple. The second option here is our value, or the property we want to change. So in this case, it's called pixel height, and this is followed directly after by the value of the pixel that we want to change. So let's just press enter on this, and we'll scroll back up and we'll see how our plot's changed. So we can now see that by changing our pixel height to 100, this has squished our plot down. So we actually just now have a plot which has 400 pixels in width and 100 pixels in height. So to show you a similar example for the get property command, so we have set property, which just lets us set the properties. To get properties, this is a way we can query information about our components. So we'll use document tools get property, and this only requires 2 arguments. So we'll use first our name, so plot 0, and second the value that we want to query. So let's do a get property of our plot, and as we could expect, because we set it here before, the pixel height value is 100. Now, we'll see also if we do a document tools get property of the value option, this would return the information on the current plot. Now obviously, since before we saw that there's no plot, it just says embedded plot window, this will actually give us back an error message because it's attempting to retrieve an unknown property value because there is no value. So what we have to then do is we can use the set property here to set a value of the plot of sign. And we'll notice that for setting the value of a plot, it's got to be a valid plot structure. So when I do this, I'll go back up to our plot again. We can now see that our plot component has the value of this plot here. So this is the plot of the sine curve from -2 pi to 2 pi. And now if we go back here and try to get the property of value, we'll actually get back the plot structure itself. We'll actually get a plot back from the get property command. In our next section, I want to discuss a little bit more about using commands in Maple. And specifically, I'm going to be talking about writing some action code. And action code is added to embedded components in Maple to drive actions in Maple documents. So simply put, what we're going to be doing is we're going to be writing some code that lets us show a different plot in our plot component. So the command we're going to be using is actually going to be, we're going to be building it piece by piece, is going to be this plots point plot command in order to simply just generate a point plot of the point at x is equal to 1, y is equal to 0. So we'll step through this, and this is handy if you want to come back and you're using this application. You can come back and you can copy this text as it is in order to use this in your own example. So our first step of creating a number line is to know how to create a point plot, because that's really what we are using with our number line demonstration. Is we're just showing a point plot of us having clicked somewhere on the plot component. So the command we're going to need to know about is the plots point plot command, and we can just use it actually in this case to create an empty plot by just using the command. So plots point plot with an empty list here will just generate this empty plot. Now this isn't live, we don't have any clickable sections yet or anything like this. This is simply a point plot of a null or an empty operator. Now there's a couple of customizations we probably want to start making for a point plot. And one good option to know from the point plot command is the axis option. And to show you what the axis option can do, I'll just use it here. So here we can set the second axis to have color equals white. And what that does is it essentially hides the y-axis for us. And this is good in these cases where we have kind of a single dimension. We want to have just a number line, so x values from -10 to 10. So that's one way we can hide the y-axis. Another way to hide the y-axis would be to use the tick marks option and to simply specify that we want our x values to be this sequence here, so from -5 to 5. But then for our y values, we want to have 0 values. So here we can see that we've got values on our x-axis, but we've got no values on our y. So this is another way that, if we kind of imagine squishing this together, we can put together a nice, convincing looking number line. So if I actually drag this up, you can kind of see how this could be used to approximate a number line. And this will actually be the selection that we'll use from the rest of this example. We'll use tick marks. So another important option to know about point plots is the view option. And what view option does is it controls our view into this plot here. So you can see here when we first generated the plot with our tick marks, there's a lot of extra white space over here where we didn't have any defined tick marks, and the y-axis is just as long as the x. And this is probably something we want to hide a little bit of. So we'll use the view option here to change our point plot to be from -5 to 5, and from y is equal to -1 to 1. We'll make it nice and tight. But then we'll also use our size option to make our plot have this smaller proportion, so that way we're not really tall on the y-axis. So that was two options I was using here. So that's view and size. All right, so now that we've built kind of the background for, or the axis for our number line, let's just add add an actual point to it. And that's as simple as just going back to our initial point plot command. And now we'll just, inside of the empty brackets that we had before, just add in a new point, 1, 0. And now we can see actually there's a point there. It's very small. You might not see it. So what we should probably do is look at some of the options for our point plot and customize our point to be a little bit bigger. Because if you have a student, say, clicking on that point, that point right there might be a little bit too small. So let's add in a few more options. We'll first of all add in the symbol option to control the symbol type. So here we'll make a solid circle, and then we'll also make the symbol size 25. So now you can see, now we've got a much more convincing number that we can, or a point that we can click on, that we can then use for our interactive number line. So moving on to our fourth section, and the fourth section is detailing how we can retrieve input from an embedded component. So we've already seen parts of this in our second section when we talked about the document tools get property command. But just as a refresh, all components, but plot components specifically, have properties that dictate their characteristics such as size and value. Plot components can also hold information about interaction with the plot, such as x, y values for clicks on the plot. So what I mean by this is that if we click somewhere on this plot, we can actually store that information as an attribute of our plot component. So, as just a refresher, in section 2 we saw that the document tools get property command can retrieve information about the properties of a component. Now you may notice here that the name here has changed. So this is, I just made a new plot component here, and it does have a different name. And just as a refresher, we'll go back in, we'll see here under component properties, the name here is plot1. So let's get the property from plot1 of pixel width, and see here that the pixel width in this case is 400 pixels. Now the properties that I'm interested in are these click X and click Y properties. And if you want to see a full list of the properties that are available for the plot component, let's actually go into our help system and we'll look up plot component, and we'll go to our plot component help page, and we'll scroll down here. We'll get down to here to our table of options. You can see that the plot component has a lot of different options. Here we have click X and click Y, which are here. These are columns for gettable properties and settable properties. So for click X and click Y, we can retrieve values, and we're going to get values back as floating point numbers. So this is an important table because we can see very quickly what attributes are available, what attributes we can query, what attributes we can set, as well as what we're going to get back when we do these actions. Now one trick with working with plot components is that in order to activate clicking ability on plots, you have to actually turn on the click and drag as the default manipulator. So to do so, what I'll do is I'll right click on the plot, I'll choose component properties. Again, we're in our plot properties dialog here, and this is an option we didn't mention before, but we have this make click and drag the default manipulator. We should make sure that this is checked, because as soon as this is checked and we click OK, we'll see that the default action on the plot turns into this arrow with a star on it, and this means that we're now registering click actions or even drag actions on our plot. So once we've done so, let's now just click here. I'm going to click right around the center or so. So we'll click at the center. Once we've activated click and drag, we can now use the document tools get property command to retrieve the click X, or the last click on our plot. You can see here this was fairly close to 0, as I said. It ends up being a little bit off of 0, but of course, we can use Maple's language in order to round this down to 0 or round this up to wherever we want to go. So as I said before, it's also important to notice that our names can change here. And if I was to change this to plot 0, obviously there's no plot 0 in this worksheet. This would retrieve just an error message. So it's always important to know the name, know where you're sending information or getting information from in your Maple worksheet. It's also important to notice that if you did come back here and did insert a secondary plot component, that this new plot component must also have a unique name. So all components in Maple have unique names. They have unique identity because we can't have overlapping components with the same name. So this is our final section, and in this section we're going to use everything we've learned in sections 1 through 4 in order to build a NumberLine application. So in this section we're going to start by having inserted a new plot component. We're going to write some action code that combines the code for generating a point plot from section 3 with the code for retrieving the XY click position on the plot from section 4. And finally, we're going to do a new step, which is to add this action code to the click action code for the plot component. So with the information from the previous sections, we're pretty much ready to go. We're ready to build an interactive number line that registers and clicks a corresponding point on a number line. So what I've done here is I've already actually added our example. I've actually added a plot component. I used, again, our plot component palette over here in order to insert a new component. And I've also already changed some attributes of the component. So the name of the plot component in this case is plot2. I've added a tooltip to our plot component. I've changed our height to be 100. And I've made sure that click and drag, the default manipulator, has been checked for this component. So with this stuff done, what we can actually start doing is now populating it with some values. So let's start by sending our new plot a new plot value. And what we'll do is we'll send it the code from the second example. So in this case, it's going to be our plot's point plot of this point plot, this point at 1, 0. The tick marks are equal to -5 to 5 at 0 as well on the y-axis. We have a set view, and then we've customized our symbol and symbol size. So if we send this to plot2, here we can see is our new plot for our plot component. Now, as we saw before, in order to register click actions, if we haven't done so already, we need to right click, go to the component, choose component properties, and make sure that make click and drag the default manipulator has been selected. So now that we've got that information done, what we can do is we can take this information, we can take the document tool set property command that we've built here, and what we'll do is we're going to right click on our plot component, and now we're going to start editing the click action code. So we'll choose component, and here we can see that there's an edit click action, edit drag end action, and edit dragged action. So we won't get into these two at all in this talk today, but let's choose to edit the click action. And what this brings up is a code editor which lets you add code that corresponds to any clicks which happen on the plot component. So I just got rid of all the extra information that was in there. Let me just copy in the code that we'd written here. So this is our document tool set property of our name of our plot component and the value and the plot that we wrote in our previous steps. So we can see now, if I save this, that whenever we click on this plot, all we're simply doing is we're just generating that same plot over again. So that's not very interesting. So what we actually have to progress on and do is we have to add in this notion of being able to click in order to get information. So what we have to do is, if we go back, and I'm going to open up this code editor again, is we have to scroll down here. I'm going to do this at the same time. So to turn on the ability to click and change the point, what we're going to need to do is we're going to have to look in the code here for our plot's point plot command. And what we want to do is we want to change this set point. We have just a static point here at 1, 0. So since we're interested in getting the clicks on the x-axis, we can replace the 1 and 1, 0 with the following code. So this document tool's get property command. So instead of 1, we're going to have document tools get property of the same plot component, so plot2, and the value that we're going to be querying is click X. All right, we'll close off our bracket. And with this information, what we're doing is whenever we click on the plot component, this is basically used then as our X coordinate axis. So I can now save my component code for my plot. And let's scroll back up here now. And let's see what happens when we click. So now when we click, we can see that we're actually using that click information in our plot command code in order to create a NumberLine application. So with that, we actually now have a fully working clickable NumberLine. Now, since all the code for this component is contained within the plot component, what we can actually do is we can take this plot component, and if I just highlight the entire thing, copy it, I can open up a new document in Maple, paste it into Maple, and then if I go back, my plot component example. So here's my plot component example with live code, which I can then save as an application, which then can be shared through the Maple Cloud. It can be shared through the Maple Player. It can be shared with your students just by sending out a Maple worksheet. So what you've done in this application is we've created this interactive content that can then be useful for using or creating interactive models, interactive discussions that use the Maple document interface.